Hello viewers, thank you for subscribing our channel. In this exercise, let us see how to apply wind load on a space frame like this, a three-dimensional RCC frame like this. Say the span is 6 meters and along the Z direction it is 4.5 meter, height is 3 meters. So this is the frame over which we are going to apply the wind load, and the member properties for columns we are going to give 230 mm by 450 mm, for beams 230 mm 600 mm for beams along x-axis, and 230 mm by 450 mm for beams along z-axis, and dead load self weight for all components. Then floor finish. Say floor finish in the sense, since it is the roof, it may be weathering course, so it is assumed as at the height of 3 meters is assumed as 1.5 kilonewton per meter square. And live load, floor load at the height of 3 meters is taken as 2 kilonewton per meter square. And wind load we are going to give. So the usage of structure in car parking, location Madurai, terrain category 2, topography, plain, and expected design life 50 years. So these are the data which we are going to give for wind load analysis. So let us open this SAT screen, click new, say space frame. Space frame subjected to wind load. So let it be file name like this, location, metric, to create a structure wizard, take frame models, pay frame, length is 6 meters, height is 3 meters, width is 4.5 meters, number of bays along length 1, number of bays along width or height 1, number of bays along width 1. Click apply. So we have generated the model of the space frame. Click OK. So this is thing. Now the member properties. So go to member properties, define rectangle. Say we have two sizes, one will be 0.6 by 0.23, click add, the other will be 0.45 by 0.23, add, close. So select this 0.6 by 0.23 we are going to give for the beams along the x-axis. So click the beam, then press Ctrl to select this beam, assign to select beams, assign yes. Now select this. This has to be given to the columns along z-axis, beams along z-axis, as well the columns I am going to give this property. So click assign, select beams, click assign, click yes. Now to see the rendered view, go to view, 3D rendering. So this is the frame which we are going to see. Now supports, so click supports, create fixed support, add, take the front view, then click the select the support. So if by clicking here, all the 4 supports will be selected. You can see in the isometric view, so all the 4 supports are selected. Assign to selected nodes, click assign, click yes. So fixed support is given now. Now to give the loading, so go to loading, then loads and definition, load case, details, definitions, click definition. Since we are going to define wind load, so go to definitions, then click wind definition, click add, let it be given as wind 1 or say some title. We're going to give intensity of the load, so click add, close. Then select this intensity, click add, So we need to give intensity. So intensity shall be calculated based on the IS 875 part 3 wind load calculations will be given. Say if let the calculated value be 0.8 kilonewton per meter squared, acting at a height of 3 meters. Click add, click close. Now let us add all the other loads, say dead load, live load and all. So as usual, close this definition, go to load case details, click add. One will be dead load, say this be DL or dead load, click add. Next will be live load, click LL, add. Third case will be wind load. So wind load, let us take wind load plus X, wind load plus X, add, that is in the positive X direction. Then fourth case, wind load acting in the negative X direction, click add. Then fifth case, wind load acting in the positive Z direction, click add. Then wind load acting in the negative Z direction, wind load acting in the negative Z direction, click add, click close. So these are the loads which we are going to give for this problem, as well the load combination. So click dead load, click add, say self weight -1, click add, and the weathering course load they have given us 1.5 kilonewton per meter squared. So click floor load as minus 1.5 kilonewton per meter squared, then acting at 3 meters. So 3 meters, the Y range will be 3 meters. Click add, close. So dead load we have given. Next live load, click live load, click add. Say that live load be a floor load as -2 kilonewton per meter squared, acting at the height of 3 meters. Then the Y range is 3, click add, click close. Now we need to define these wind load acting in the plus X, minus X directions. So let us do one by one. Click wind along positive X, click add. So wind load, here we click wind load. So actually wind load passing the X direction, so windward side, and this is leeward side, -X is leeward side. And when wind acts along windward or leeward side, the other two sides should be treated as side wall phase. So we need to give values for -Z. So X, let us give factor 1, click add, and say in the leeward side also factor 1, click add. And then this walls, say side wall face +1, click add, and side wall face -1, add. Click close. So let us see how these loads are acting. Just by clicking on this, you can see or visualize the load. Say we have given a positive X direction. So X direction, this is positive. So wind acting on this. So this is the windward side, and this side is the leeward side. So wind along windward side should be acting like this. That's why we have given X value as 1. And this -X, that is this leeward side, if you click, so this is the force. Say you can visualize the force acting on the leeward side, but it acts along, the general common is acting along positive X axis, so along this, so this acts like this. And these two, say this and this, are the walls. This should be treated as wall. This is windward side and this is leeward side with regard to +X, and these two are the walls. So wall side, if you click -Z, plus 1, say minus z means z, this is the positive direction, so this is the negative direction, so this is plus 1, and then if you click this, so this will be the, say this is minus 1, therefore this is the force acting in the opposite direction of z. So you can see the visualize this wind force acting here, if you can see the difference. So this is the wind force acting here on this side. You can see the arrow. So this is the arrow here, this arrow here, this arrow here. So we can visualize the loads like this. Now let us go to minus x. So click add. So minus x means click wind load. So in the windward side we need to give minus 1. Click add. Similarly in the leeward side also minus 1. Click add. And along z, the side face or sidewall or face, minus 1 we should add. Similarly plus 1 we should add. We should have 4 types of loads with regard to wind. So I will explain here. So you can visualize here. Say this is the minus x direction, that is x direction plus is this side, this is plus side, this is minus. So if you click this, you can visualize the load. So load acting opposite to this x axis, so therefore it is minus x, and this is the windward side with regard to this minus x direction. This is the leeward side, so you can very well see the leeward side, force acting on the leeward side. And these two are as before, these are the side walls. So if you click this, you can visualize one force, that is one force acting in the negative z direction, and the other force acting in the positive z direction. Okay. Similarly, click plus z, click add, click wind load. So wind load, windward side plus 1, click add. Then in the leeward side, this is the leeward side also plus 1, add. And side wall for x, so side wall for x we should take this, so plus 1, add, and similarly minus 1, add, minus 1, add. So close this. You can see, say this is the z direction, positive z direction. So that is z positive is this, from this side is z positive and opposite is z negative. So this is z positive. So plus 1 refers to acting in the positive z direction, and this is that is the windward side, and this is the leeward side. Plus this is also plus because here plus z is this. Then minus x you can visualize here. So minus x means the side walls. So side walls you can see. Say the side. These two will be side walls in this case. If the windward and leeward side are considered this is, if this is windward and this is leeward, these two should be considered as side walls. So the force acting on side wall like this. Similarly, force acting on the side wall like this. So these two we should take. Similarly, for minus z, click add, click wind load. So on the windward side, we should take minus 1, windward side minus 1, click add, and leeward side, this is the leeward side, minus 1, add. And for x it should be side wall. So side wall, click side wall, minus 1, add, and for side wall plus 1, add. Click close. So you can very well see here. So this is minus z direction. So if you click this, say you can see the load. So load acting in the opposite of z direction. Positive z direction will be this side, and opposite to this will be negative. Therefore this is this, and this will be, this is windward side, this is leeward side, and then these two are these two side walls. So you can see the wind force acting on this side wall. This will be highlighted where this force is acting, and the arrow will represent where it is acting. Similarly, if you here, so this is highlighted. Therefore, this is the this wall, wind force acting on this wall. So these two are side walls. So the arrow represents the direction of the wind load. So this how we should define the wind load for any building. plus x minus x plus z minus z. In plus x we have x1, then this is leeward side also 1, then these two for side walls 1 minus 1, and minus x, this is for the windward side minus 1, leeward side also minus 1, and these two for side walls, one should be minus 1, other should be plus 1. Here z direction, so z direction windward side 1, leeward side also plus 1, and these are the side walls 1 and minus 1 or minus 1 and plus 1, and then minus z direction windward side minus 1, similarly leeward side minus 1, and these two are for side walls minus 1 and plus 1. Next is the load combination. So go to load case details, click add, click auto load combination, choose our code IS 800 or IS 465 IS 800, generate loads. So these are the 34 types of load combinations. So click add, click close. So we can see very well the load combinations here as per the IS code. So this is how we should define the wind load. So once the loads are given, then we can go to analysis. We can do analysis commands. You can give, say, perform analysis, all, then add, then close. Then before designing, select everything, go to design. These are common as we do for any problem. Click concrete, select the IS 456 code, select parameters, bring all the parameters this side, take FC, FI main, FI secondary, maximum secondary, then minimum main, minimum secondary, bring to the side, click OK, define parameters, then FC, click assign. Since the members are selected, FI main, say let it be 415,000, click assign, then FI secondary 15,000, click assign, maximum main, say let it be 20, assign, maximum secondary, let it be 12, assign, minimum main 12, assign, minimum secondary 8, assign, close. Then select the beams parallel to x-axis. Similarly, beams parallel to z-axis, go to commands, design beam, click assign, close, select the columns. So select beams parallel to y, commands, design column, click assign, close. Then select all by clicking Ctrl A, then go to commands, take off, assign, close. So this completes pre-processing, and then we have processing and post-processing. So the new thing which we have learned in this exercise is assigning or giving the wind load definition and giving the wind load coefficients as 1, 1, minus 1, plus 1, minus 1, minus 1, 1, minus 1, then 1, 1, minus 1, plus 1, minus 1, minus 1, 1, minus 1 for the different directions, windward, leeward, as well the side walls. So the rest will be the same as in other examples. So with this, let us stop, and please subscribe our videos to make it reach the concrete, that means civil engineers. Thank you.